Okay, we're going to do this algebraically. I do want to emphasize that normally you can't do this anyways. So I don't want to overemphasize this. We're just going to do this for completeness. I'm going to solve for t, and when I'm all done, hopefully I'll call it the right thing. To solve for t, I have t way over in this exponent. It's really kind of buried. The first thing I want to do is divide both sides by 10,000. So I'm going to write down that a over 10,000 is equal to ms. Now what I need to remember is that logarithms are the only way to get stuff out of that. So what I want to do is take the natural logarithm of both sides. I'm going to say the natural logarithm of the left-hand side equals the natural logarithm of the right-hand side. Now I just want to do this in one step. Remember that the natural logarithm of something to a power, you bring down the power. So just so I don't clutter everything up, I'm going to just bring down the power right away. And I'm going to get the ln of 1 plus 0.04 over 12. And remember, all I did was I took the natural logarithm of the right-hand side and then brought down the 12t. Unfortunately, we're trying to solve for t, so I have to divide both sides by the 12, and I have to divide both sides by this horrible logarithm. So let's do that. I take the left-hand side, which was the ln of a over 10,000, and I'm going to divide by 12, and I'm going to divide by that horrible logarithm mess. So here we go. And there's no nice way of combining this logarithm with this logarithm, so resist the temptation. There we go. That's equal to t. Now you can see, by the way, that t is a function of a, right? In fact, it's the inverse of our original function, but we're plugging in a to get t. So that's how you find the inverse of a function algebraically. You just solve for the original input variable. A lot of times they'll say switch x and y and divide by and solve for y. This notation is better. It just says exactly what we want. We're plugging in the answers and we're getting the original input, and you can see that that formula is sometimes a mess.